When you start using a CNC router, you discover that even a trivial design will often require several different tools to produce. You might have a V-bit for cutting lettering or doing some engraving, a flat bit to do roughing or flat bottoms of pockets, and if you have any 3D shapes, curvy bits, or want insides of your pockets to be rounded, you have a ball nose. And there's lots of other bits for lots of other reasons. Between each tool change, you have to redo all your zeros and make sure your tool length changed, so you have to account for that. And you end up spending a lot of time babysitting the machine. You might only have 5 minutes of runtime between tool changes, sometimes even less. So you're sitting there doing almost nothing, but just waiting for the machine to need you to change its tools. It's kind of annoying. Industrial machines have big complex tool change systems. The spindles have pneumatic grabbers that can pick up a tool holder and reliably pick it up and hold it in place. And they have mechanisms to hold those tool holders and get them into where the spindle can grab them. But that really hasn't been the case with these smaller desktop machines like I've got here. Tool change spindles do exist now for these, but they're kind of expensive. You might be spending $1,500 if you buy off AliExpress, but then you have to add pneumatic valves to control the grabbing mechanisms. You have to run all those air lines. You need an air compressor with actually quite a bit of air capacity. You're adding a lot to the machine, not to mention tool holders and all of that. All in, I think you'd be hard to do a conversion for under about $5,000. Luckily, we have a different option here. The guys over at RapidChange came up with a different approach. They asked, why do we need an expensive tool chain spindle, tool holders, all of that? Could we just have the spindle thread a collet nut on just like you do by hand? And it turns out you can if you make a little bit of a clever mechanism, which they have and they'll sell you now. So I bought one of these RapidChange tool changers and I'm going to install it on my machine. So much for this being an ASMR wrapping pull. Before I can finish the linkage for the lid, I want to replace the wire that's on here. I want a quick disconnect in the middle of it so it's easier to take it completely off the machine when I need the full bed. And there was also a little bit of damage on the wire from shipping, so we're gonna go ahead and pull this apart. When something doesn't fit, there's always wire cutters. This is the wire I'm going to use. It's a single length of wire. I'm just going to cut it at about a foot off the one end, put that on the tool changer, and put the other side on the control panel. But now I've got another thing that doesn't fit. So now I have a reamer. A little bit of handyman secret goop. All right, we can work on the other end of this wire that's going to the control panel. Power and ground, we just need gonna put a ferrule on quick because stranded wires are evil. And then we need to extend the 3 for the 2 inputs, the IR signal, the Toolsetter, and then the output to control the dust cover. Those need to reach all the way to the other end of the panel, so I hate crimp connectors. I guess 1 out of 3 is not that bad, right? Now that I did it right the second time, I'm going to add some labels to this. The little heat shrink label printer labels are awesome for tiny wires. Except that they don't go over the ferrules I put on. Wire cutters to the rescue again. I'm not going to heat shrink these right away because these wires are all going to get trimmed to length in the once they're installed. And there were already a couple extra blanks, so I just fished it through, and I made sure the cable gland I picked earlier was going to fit in this hole. The ferrule that I did and cut off and did again turned out to be useless because these needed to be forks, not ferrules to go to the terminal block back there. And I'm just going to piggyback those wherever I can find a place they'll fit. Three control signals need to get fished over to the Mesa I/O board. Connect the dust cover to one of the outputs. And both the outputs and the inputs, I have the commons being ground. And then the IR beam and Toolsetter can each go to an input. Alright, that's it for the electrical install, so let's look at getting this thing mounted. I want to put the tool changer on the front right corner of the machine. I rarely need the full width, and that's going to put it right next to where my tool cart is, and just make it easy to get to. I took some drawings of the workboard, including where the existing mounting screws are, because I don't want to hit those. And we're going to put the tool changer up on a riser that's going to give more room for long tools to stick out the bottom of it. So there's going to be pockets that extend all the way into the MDF, not down into the aluminum of the machine, but just through the MDF workboard. I'm going to use epoxy for this because I don't want the moisture causing warping or shrinking after it's installed. Mixing and mixing and more mixing. And pour it into a new cup and even more mixing. I realize I probably should have used some filler with the epoxy, but we're just going to go with it because I don't want to do any more mixing. A table saw is going to be a convenient flat surface to clamp this to. And then this stuff really does need 24 hours to cure, so we're going to let this sit for a little bit. That's why you're more careful with where the design is zeroed versus where you zeroed the machine. Much better. Clearance height. Yeah, that's another thing to be careful about. I'm going to re-zero this, just poke it down in the hole. That's going to be good enough to get this realigned. I don't even know what I did wrong there. Yeah, I just barely got away with that. So yeah, now we're going to be done for the night. It's the next morning and I have a functional brain again. So we're going to start with the holes for the threaded inserts. There's a little recess, so the top will be recessed 2 or 3 millimeters below the surface, and then drilled down so it almost goes through the MDF but not quite into the aluminum. Each end of the riser has a dowel pin to perfectly align it with the workboard. Each end of the tool changer also has an alignment pin, so the tool changer is held to the riser and that's held to the board. Then we need to drill all the way down through the riser for the main mounting bolts. And this is why I didn't do the threaded inserts yet, is I don't want this drill bit to run into those. Alright, the next operation is cutting the main pockets for the tools, and that's going to be a really aggressive cut, so we need to actually secure the riser to the table. So I'm just using 2 of the mounting bolts, which should be clear of the bit. Eight holes, 1.5 inches in diameter and almost 3 inches deep, make a lot of sawdust. And I'm going to need a bigger vacuum. Yep, somewhere I miscalculated the length of the alignment pins and how deep those holes need to be. And with that mounted, we can start looking at some of the electronics. So dust cover works. Awesome. What about the IR? No, I got nothing going on with the IR. Toolsetter button works. What you can't see through my fat hand is that green LED was only slightly changing when I was blocking the IR. And I went back and forth with support, and ultimately they're sending me a replacement control board. So while we're waiting for that, we're going to just have to keep going, testing the load and unload functions and maybe get to the Toolsetter. There are links in the description to a GitHub repo for this machine's configuration and another repo that's set up for somebody else who wants to use Rapid Change with LinuxCNC. I just want to give you the quick version of what's involved here. This is a G-code file for testing the tool changer. What it's doing is saying change to tool 1, change to tool 2, change to tool 3. The T is saying which tool number. M6 is a command saying do the tool change now. We need the machine to understand that it has a rapid change and what to do with that. One of the features in LinuxCNC is that you can remap some G and M codes to give them custom functionality. We're saying whenever it sees M6, we want to run this G-code file called RapidChangeM6. We need to do a little bit of setup before that. We're going to run this prologue that's written in Python. The prologue looks at all of the configuration that's in the init file with where's the tool changer, what speeds, locations, does it have an IR, dust cover, all of these options. Then it looks at what is the current tool and what tool has been selected by the most recent T command. It's pretty straightforward. It's just figuring out, if we have a tool and we need to drop it, do we want to do it with the tool changer, or do we want to ask the operator to drop it manually because it's a tool that isn't in that doesn't go in the tool changer. Then we go into the G code and we have things that say, if we need to do a manual tool drop, go to this location and then, ask the user to change the tool. If we're doing our change in the tool changer, where do we go? Where, run the spindle, do the things. I have to give a shout out to the Rapid Change Discord. There's a lot of really helpful people there, and particularly I got to point out Oddname, who has their own LinuxCNC remaps to do this. I ended up writing my own because I wanted it to work a little bit differently than theirs. Plenty of people have reported that theirs works too. Check out the Discord, check out Oddname's version. Okay, all of that said, let's see if this will work. So we're going to ask it to pick up tool number 1. That's the closest pocket to the camera. Okay, that's not too bad. So let's ask it to change to tool number 2. So it's going to need to go drop tool 1 and then go pick up tool number 2. Yeah, and that is really okay. That's not what we wanted. Okay, I tweaked the speeds and rates a little bit, and ignore the blurriness. But that was good. We picked it up, and we dropped it. So I think before we can do a lot more testing, we actually need more tools. And that center drill is pretty much the only tool I have that would hold in the collet that wouldn't fall out just under its own weight. So another thing the Rapid Change guys figured out is if you 3D print these little TPU discs with the right size hole, you can stick them to the front face of the collet nut. And they're TPU, so it's just a very rubbery plastic, and they'll just give it enough friction to hold a bit from falling out. I redrew some because I needed sizes that they didn't sell, and anyways, I have the printer, printed those up, and then just put a couple little dabs of CA glue on the top side of the disc, a little bit of accelerator, and stick the tool up in the collet. We snug it up because now the tool is held straight, so we know that disc is aligned right and it's not going to just wobble out, and it's going to be reasonably balanced. I made a few refinements to the scripts off camera, and now we're going to run the test script I showed you earlier where it's going to pick up each tool in sequence. It's going to go pick up tool 1. It's going to return to the position where that command was issued from. And now it's going to go put down tool 1 and pick up tool 2. That horrible noise is nothing to do with the tool changer. I screwed up somewhere and ended up with the tool changer skewed about not quite a millimeter from end to end. I don't know how I did that, but it meant the nut was rubbing on the side of the tool changer, so we're going to make a little adjustment for that in the configuration. All right, it's been a couple days, and the new control board showed up, which means we're going to be able to test the IR beam and the Toolsetter. We're going to get that hooked up quick, but I also wasn't happy with the hot snot wire securing. The problem with a cable gland here is there's not enough depth. You just run into the control board. I was sanity checking before filming, and the dust cover wasn't working. And I think I might see why. I think there's supposed to be a chip there. Much better. The green light doesn't stay on, and it works with the IR beam. The Toolsetter blinks. You can see it changing blue to red. And the dust cover works now that it has the chip. And now we can test using the IR beam as a safety. So it'll pick up the tool, and it'll pause, and you'll see the green light comes on. It pauses, and green light's still on, so it knows there's a tool in it. We're good to go. I made a big mistake. I was testing the height the IR beam triggered when I had the tool down in the pocket and got distracted, came back, and went to jog the machine and jogged the tool through the tool changer. Now, the tool wasn't running, so it didn't cut up the tool changer, but it did rip up the workboard. It basically tried to rip out where the threaded inserts are and just pulled the MDF apart. I could try to replace this, but I don't have a piece of 1-inch MDF laying around, and I could glue something up, but that'd take longer. I think the quickest thing to do is just going to be repair this this piece of workboard. I don't want to remove this piece of workboard because then we'd be moving the alignment pins around. So I think we're just going to get some glue in there and clamp it right down to the board because, I mean, that it's made to be clamped to, right? I don't trust the CA glue alone, so I'm going to stick some dowels in pretty much everywhere I can fit a hole for one. Now, before we get back to testing, I've still got the control box hanging out from doing the LinuxCNC conversion. I'm going to just go ahead and get that put away because we know all the wiring is working. Now we can get back to the IR beam. What that needs to do is when we're picking up a tool, right here we pause and have to check if the IR beam was broken by the nut being on the collet. In the G-code, that's pretty straightforward. We check if the IR beam input has been configured, and if it is, we read that input and check if it's 1 if we're looking for a tool, or 0 if there's not supposed to be a tool. Okay, light off without a nut, and then as we go pick one up, there the light is on. The Toolsetter shouldn't be that complicated, and it really isn't. We want to take the tool, probe down until we hit the switch, and then treat it basically like we do the Z-puck that we use to find the top of our workpiece. The complexity is when you want to know both a tool length and the top of your workpiece. G-code and LinuxCNC support this, but getting both the subroutine for doing the Z-probe and the Toolsetter working is a bit of a pain. In both cases, the probe G-code gives us the exact position the switch triggered, but then we have to calculate into what is the actual tool length and where do we want to set the work coordinate. And G-code has multiple layers of offsets and adjustments that apply to different variables in different ways. So I ended up kind of being a trial and error to get to the right calculations, which is why there's a bunch of debug messages here. Let's make a real thing. We'll pick up a random tool to use with the Z-puck. Once it sets the tool length, we'll manually jog the machine over and use the Z-puck just like we did before we had the rapid change. Now we'll just let the program run. It's going to drop that tool, pick up a V-bit. I should really look at these probing speeds. It could probably probe a lot faster. Even though I used the other tool to set the work offset, it's still going to cut perfectly, even with these fine V engravings. Still the same program. It's going to drop that V-bit and pick up a 1/4 inch flat end mill. With no finish, this lettering is almost invisible, so we're going to wipe a little oil on here. And I think I'll call that a success.